Let us understand how to find out natural frequency for a given system by using Holzer method. If we observe the given question, then there are three rotors with mass moment of inertia are given. And this mass moment of inertia I1 is equal to I2 is equal to I3, which is equal to 1 kilogram meter square. So we will consider this is the first rotor, this is second rotor, and this is third rotor. So we will mention here the mass moment of inertia for each rotor. Now in between these rotors there are two shafts, and the shaft stiffness is also given. Kt1 is equal to Kt2, which is equal to 1 Newton meter per radian. So we will mention here the shaft stiffness as a Kt1 and Kt2. Now for this system we have to find out the natural frequency. Now if we observe, there are three rotors with three mass moment of inertia, and for these three rotors there are three angular displacement. So these angular displacement are, here is theta 1, here is theta 2, and here is theta 3. Now for these three angular displacement there are 3 degrees of freedom, and therefore we have to find out three natural frequencies. So we will consider, we have to find out omega 1, omega 2 and omega 3. So we will make here the question mark. Now we will understand the type of this given diagram. Now if we observe, at the end points there are rotors, there is no any shaft. So this type of the diagram is semi-definite system. So I will write here the type is semi-definite system. Now for this semi-definite system, one frequency is always 0. Now if we observe for the diagram, because of three rotors we have to find out three natural frequencies. But because this system is semi-definite system, no any shaft at the end points of the diagram. So either left hand side or right hand side there is no shaft, but there is rotor, and therefore one frequency is always 0. So we will consider here omega 1 is equal to 0. Now we have to find out remaining two frequencies. So how to find out? So we will apply the Holzer method. So this is the trial and error method, and we have to show summation of I omega square theta is equal to 0. And when this summation of I omega square theta value 0 is achieved, then that frequency is known as natural frequency. And because this is the trial and error method, we have to assume the value of omega. So we will first assume the value of omega in between 0 to 1. So we have to prepare one table. First we will write the frequency. So first frequency we will assume here omega is equal to 0.5. So I will write here omega is equal to 0.5. Now for this frequency 0.5, if we observe, there are three rotors, and therefore there are three positions. So I will write here position number 1, position number 2 and position number 3. So next column is for position. So I will write here 1, 2, 3. Now value of I. If we observe, at position 1, I1 is equal to 1. At position 2, I2 is also equal to 1. At position 3, I3 is also equal to 1. Now we will fill up the next column. There is omega square. So omega square is omega, that is 0.5 square. So we have to write here 0.25. Now we will move to the next. Now here theta. So for position 1, 2 or 3, value of theta is not known. So remember, to solve this problem we have to assume theta value at position 1 is always equal to 1. So I will write here in the diagram theta 1 is always equal to 1. That we have to take. So I will write here as a 1. Then next we have to now solve the table for only position 1 up to end. Now what is the value of I omega square theta? So I omega square theta, if we observe, here is 0.25. And for position 1, summation of I omega square theta, so we have to repeat this value 0.25. So how to repeat? Why to repeat? Because this is the first position. So for second position, we have to add the previous value also for I omega square theta. Now next one is KT. So for KT, if we observe, here is the value of KT1 we have to apply, that is 1. That is also mentioned in the question. Now next, summation of I omega square theta by KT. So summation of I omega square theta and this KT. So we have to refer previous two columns and its value is 0.25. So now this 0.25 I will write with the help of red marker. Now we will move second position. So for second position we have to write the value of theta. So how to write? So we have to observe the values with red marker. So we have to take difference between this theta column and this last column. So 1 minus 0.25. So here I will write 0.75. So this is the value of theta. Now next is I omega square theta. So if we observe, here is I omega square theta. So 0.75 multiplied by 0.25, that is 0.1875. Now next is summation of I omega square theta. So we have to add these two values to write here. So just I will write here plus sign. So 0.1875 plus 0.25, that is 0.4375. Then next column is KT. So KT2 is also equal to 1. Now summation of I omega square theta by KT. So if we observe the previous two columns, then answer is 0.4375. Now we will move to the third position. So for third position, how to find out the value of theta? It is 0.75 minus 0.4375. It is 0.3125 multiplied by 0.25. So it is 0.07812. So we have to write here 0.078125. Now how to write the summation of I omega square theta? So we have to add previous two values. So we will add here plus 0.1875 plus 0.25. It is equal to 0.5156. Now this answer is important because the third position is the last position, and for the last position we have to show summation of I omega square theta is equal to 0. But if we observe here, it is not equal to 0. That means we have to again consider the second frequency. We will consider the next value of omega. Omega is equal to 1. Now for this frequency we will write the three positions because of three rotors, 1, 2, 3. Next the column is for I. So mass moment of inertia I1, I2, I3 is equal to 1. So we will write here as a 1. Then omega square. So 1 square is 1. So for each position we will write this frequency. Now next is theta. So for the position 1 we have to assume theta is equal to 1. So I will write here. Now I omega square theta. So we have to multiply previous three columns. So here is 1. Summation of I omega square theta. For the first position we have to repeat the same value KT. So here KT1, for the first position KT1 is 1. So we will write here, and summation of I omega square theta by KT. So here previous two columns, 1 divided by 1, that is equal to 1. So this first position is getting completed. Now we will move to the second position. So how to decide the value of theta 2 at position 2. So we know that this 1 minus 1. So 1 minus 1 is 0. Now next I omega square theta. So 1 value is 0. So here is 0. Now summation of I omega square theta. Now it is important. I will write here plus and 1 plus 0, that is 1. Then kt. So for kt2 it is 1. So we will write here 1. And summation of I omega square theta by kt. So 1 divided by 1, that is 1. Now we will move next. So for third position, how to decide the value of theta? So 0 minus 1. So 0 minus 1, that is equal to minus 1. Then here I omega square theta. So if we observe, here is 1 multiplied by 1 multiplied by minus 1, that is minus 1. Now summation of I omega square theta. So we have to add all these three values. 1 plus 0 plus minus 1. So here 1 minus 1 is 0. Now we have to show summation of I omega square theta for last position is equal to 0. So if we observe, here we get this value 0. So we can say that next frequency, that is omega 2, is equal to 0. So we will write here omega 2 is equal to next frequency is 1. Because for frequency 1 we have to get this summation of I omega square theta is equal to 0. And omega 1, because of semi-definite system, it is 0. Now we will find out the third frequency. Now we will assume the next value. So next value I will consider here 1.5. So for omega is equal to 1.5, we have to solve the question. So again the same position 1, 2, 3, I 1, 1, 1, omega square. So 1.5 square, 2.25. So 2.25 for each position. Then value of theta. So for first position we have to write here as a 1. So I omega square theta multiplication is 2.25. Then summation of I omega square theta is also equal to 2.25. Then kt is 1 and summation of I omega square theta by kt, that is 2.25. So I will write here with the help of red marker. Now value of next theta. So for position 2, how to find out theta? So 1 minus 2.25. So it is important. 1 minus 2.25. That is equal to minus 1.25. So with the help of calculator we have to calculate this. Now I omega square theta. So we will multiply here, multiply with 2.25. That is minus 2.81 minus 2.8125. Now next is summation of I omega square theta. So we have to add this plus 2.25 plus 2.25. So minus 0.5625. Now it is important, here one sign is minus and this 2.25 is plus sign. So just add this and then kt is equal to 1, and now last one is summation of I omega square theta by kt, that is minus 0.5625. So minus sign will remain as it is. So I will write this with the help of red marker, minus 0.5625. Now next one is important, how to calculate theta at position 3. So this column value minus this. So if this last column is having minus sign, so minus minus will become plus. So how to calculate this? So while calculating we have to write here plus 0.5625 minus 1.25 minus 0.6875. Then next summation of multiplication of I omega square theta. So multiply with 2.25 minus 1.5468. Now in this value we have to add the previous two. So we have to add. But if we observe the previous value is having minus sign. So just write the minus sign. So minus 1.546875 is there. So I will add here minus 2.8125. 2.8125. Then I will add plus 2.25. So here there is minus 2.10. Minus 2.109. Now if we observe, we have to show summation of I omega square theta is equal to 0. But here this value is negative. That is minus. Now remember, if we consider any next value and suppose summation of I omega square theta value is positive, then the natural frequency lie in between these two frequencies. That is our next assumption, and this 1.5. Because in between minus value and plus value there is 0. So with the help of graph we can find out that value. So we will assume the next value omega is equal to 1.8. So next value is omega is equal to 1.8. So position 1, 2, 3, I 1, 1, 1, omega square 1.8 square. 1.8 square, that is 3.24. Then theta. Now from here we have to start calculate. 1. Then I omega square theta 3.24. Summation of I omega square theta 3.24 kt 1, and here 3.24. So I will write this in with the help of red marker, 3.24. Now next theta value 1 minus 3.24. So 1 minus 3.24 minus 2.24. This is important step. Then I omega square theta. So minus 2.24 multiplied by 3.24 minus 7.2576. Summation of I omega square theta. So we have to add this previous value. So plus 3.24. It is minus 4.0176. Then next kt is 1. And now summation of I omega square theta by kt. So here is minus sign, minus 4.0176. Now we will move to the next. So next theta calculation is important. Minus 2.24 minus 4.0176. So minus will become plus. So here plus 4.0176 minus 2.24. That is 1.776. Then next I omega square theta. So multiply with 3.24. 5.7594. 5.7594. Now we have to add the previous value. So previous is minus 7.2576 plus 3.24. That is equal to 1.74. Now we have to observe this value. So this is the positive value. So if we observe the omega, that is the natural frequency, is in between 1.5 and 1.8. Because for 1.5 there is negative value and for 1.8 there is positive value. So we will find out the third natural frequency with the help of graph. To plot the graph, we will prepare one table. For each value of omega, we will write the calculated value of summation of I omega square theta for the third position. So for 0.5, it is 0.5156. For 1, it is 0. For 1.5, it is minus 2.109. And for 1.8, it is 1.74. Now on the horizontal line, we will plot the values of omega. So we will take any particular distance. So you can take here 2 cm or 4 cm as per the space available. And we have to start from 0. So here is a vertical line and the point of intersection is 0, then 0.5, 1, 1.5, 2, 2.5. Now on vertical line we have to plot the values of summation of I omega square theta. So for I omega square theta, some values are positive and some values are negative. So here from 0 upward side we have to take plus 0.5, plus 1, plus 1.5. And on downward side we have to write minus 0.5, minus 1, minus 1.5. Now we will plot the points. Now for 0.5 it is plus 0.5156. So here is 0.5 and here is 0.5. So after some distance we have to take 0.5156. So I will plot here one point. Then next for frequency 1 it is 0. So here is 1 and then summation of I omega square theta is 0. So second point is here. Then next is plus 1.5. It is minus 2.109. So for 1.5 here is minus 2. So we have to take here the vertical straight line and horizontal line. So after this minus 2 there is minus 2.109. So we have to take some distance below to minus 2 and we have to plot here one point. Now next is 1.8. So in between 1.5 and 2, so here after this middle point there is 1.8 point and the value is plus 1.74. So here is 1.5 and here is 2. So in between 1.5 and 2 approximate middle point is 1.74. So here is 1.8. Now we have to find out the point of intersection. And here is horizontal line. So here is the next point. Now we will join the point. So we know that one frequency is 0. So we will also take because of this semi-definite system. So here is 0. Now we will join the points. Now here we have to join in this way. And now these 2 points we have to join. Now if we observe, we know that natural frequency is the points where this point of intersection. So first point of intersection is 0, second is for the frequency 1 and now third is. So it is in between 1.5 and 1.8 but it is nearly equal to 1.8. So we can say that omega 3 is approximately equal to 1.75. So the third frequency is 1.75.